Great. Welcome to a nice Thursday morning session of ArcGIS Runtime, building cross-platform apps. My name is Rex Hansen. I'm a product manager for ArcGIS Runtime. I'm going to be joined by a number of our experts here on the panel. We're going to do a little hot swapping up front here with a lot of devices, machines, a lot of cross-platform action going on here. So we got a lot of things working up here. It's going to get a little hot. It's okay. You should see a lot of activity. I'm joined by Mark Baird, product lead for Java Android. Hello. Also joined by Lucas Danziger, product lead for Qt, and also Morten Nielsen, who's the dev lead for .NET. So we'll be taking you through a run of cross-platform capabilities and technologies with ArcGIS Runtime this morning. So first, just a brief agenda. Cross-platform overview. We'll just have a brief discussion about cross-platform, what it means, maybe some questions that have come up with respect to cross-platform in general. We've toyed with the idea of calling this the cross-platform cage match, actually, in the morning, but I figured that might get a little hostile. So keep it tame. We've got a couple of cross-platform options we want to cover, Java, Qt, and .NET in that order. And so we're going to take a look at those. But first, we're going to start with a couple of questions, native versus web. This is a common question that comes up with two broad strategies for being able to tackle applications and a variety of pros and cons. I'm going to start with native apps. So generally, with native apps that are installed on the device, you're working with device capabilities, and so you can work with operating system APIs. It's all built in, depending upon the devices that you're working with. Generally, you get the best performance because you're working on board with the system with access to resources such as GPUs and sensors that are available on the device, and so that's ready-made and accessible by native APIs. Both connected and offline, right? So being able to work connected when you have connectivity, but also what's critical here too is being able to work with offline data resources, content. And so a critical need there for a lot of folks that are being able to have either a workflow that requires partial connectivity or being offline completely at some point. Native SDKs are really designed for that with local access. Of course, oftentimes it works well when you know what devices you're targeting. So if you're within an enterprise and you know the devices that are being delivered to your customers, oftentimes you can target and you can optimize your development effort to make sure that you're taking full advantage of those resources, which is key. Of course, ArcGIS Runtime SDKs, what we're covering in this session, are going to target these native developer experiences. And the Runtime SDKs that we're looking at here actually will target one or many platforms. Obviously, many platforms, cross-platform, being able to take advantage of a single development environment, shared code as much as possible, and targeting multiple platforms. Now, with web apps, obviously, a website is maintained, managed, downloaded from a web server, so a centralized location. There's a benefit there that you're updating in one place. You can actually target a wider range of customers or clients because generally you're working within a browser. The browser itself is already an app that's installed on a device. And so being able to access that website, update that website out of band is fairly easy. Generally, though, you're working in a connected environment, right? So it requires some level of connectivity. So if you need to go offline or you need partial connectivity, web apps generally are not an option or a choice that you'd like to go with. Our API of choice in this case is the ArcGIS API for JavaScript to create web client solutions. Now, I have to admit, there are some of these capabilities are being blurred with different technologies that are being introduced, such as working with progressive web apps that are able to take advantage of some local resources, working with WebGL that takes advantage of local GPUs to be able to enhance performance within the JavaScript of the web realm. So there's a couple of different technologies that blend this, as well as something like React Native, where you're building in JavaScript, using your JavaScript skills, but you're targeting native applications. So there's a couple of different blurred lines here. We're working with native developer technologies that will enable you to provide a great sort of managed API solution and consistency across these platforms too. So one of the benefits here of working with a cross-platform solution is shared application code. So being able to build out one solution, share as much business logic as possible, and be able to reuse or redistribute that to multiple platforms as needed. Generally what this means is that you need to have good design patterns in place, right? So the managed APIs that we'll talk about here today have a set of design patterns that enable you to not just be a single developer, but a team of developers, a group of developers building with good design and good patterns and best practice. They're enforced by those developer technologies. What this does is it enables you to make your app available to more users. So even though you're, let's say, leveraging your native development skills, you're a .NET developer, you want to target iOS, Android, and Windows. You're a Qt developer, you want to target every platform. You're a Java developer, you want to target Windows, Mac, or Linux. you're able to take advantage of those skills and target multiple platforms as necessary for your users. Now, there are a couple challenges here. With additional platforms and additional variables comes additional testing. And so some nuances do creep in depending upon really device or operating system differences. So a couple things to think about there. Oftentimes this means that there's some conditional logic within your business logic to be able to accommodate for different platforms. Something to think about. That also means your user experience may vary. Some technologies, such as, let's say, Xamarin Forms, provides a nice common UI layer, but that might be a little too general for very specific application needs. So oftentimes that might mean that you need some custom UI logic to be able to wrap or access your business logic. So there's going to be some divergence there, potentially. Platform idiosyncrasies, again, different platforms, different capabilities, different issues crop up. So being able to consider those, and that really factors into your testing and the architecture of the application that you have to be able to accommodate for that going forward. And development cost. Obviously, with additional testing, there's additional time, and additional operating systems that you target, additional variables, there's additional cost. Sometimes this requires some retraining. So if, let's say, you're working in Swift, but you want to be able to target Windows and Android, you might need to train your developers, your development team, to work in a cross-platform technology. Right? So there could be a cost associated with that. All right, so how do you choose a cross-platform SDK when you're going to be building a native app? Well, one critical thing here is taking a look at what your business, your user requirements are. What do your users expect? What operating systems do they need to be able to run on? What do they need to be able to take advantage of? That's the first question. The second one is, what is you or your developer team's skill set? What can you guys start developing in for rapid application development as soon as possible? Or do you need to train in a specific area? So ideally, you're choosing a skill set that matches the operating system needs, application requirements, and you're able to enhance or take advantage of that skill set. Now, as I mentioned before, I'll repeat these again. There's multiple options available here in the industry with respect to Java targeting multiple platforms with a Qt technology, or .NET Xamarin-based capabilities. Based upon these industry standards, we've built a set of managed APIs, SDKs, on top of ArcGIS Runtime. We built a common core, so there's a lot of functionality that's shared at a common level within the core of the ArcGIS Runtime product, implemented at C++ natively to optimize for performance and access and consistency. What's key here is that we're targeting multiple platforms, and those platforms themselves, because we're building out natively, will operate consistently regardless of which technology you choose. So we're going to be highlighting 3 separate SDKs here, Java, Qt, and .NET. If you're using, let's say, Java, Qt, or .NET to target Windows, it's the same binary. It's the same runtime core binary. You might just be using a different managed language to target Windows in that context, right? So you should expect consistency there based upon our common native core. And with that, without further ado, I'll hand it off to Mark, who will take us into the Java world.
Thanks, Rex. So just take a look at the offering we have from the Java SDK runtime. So some people love it and some people hate it. I don't know where Morton sits on that scale, but the fact is Java is everywhere. And that actually makes it a very good platform for writing applications once and deploying it to many platforms. Now, the current release of our SDK is there to support Windows, Linux, and Mac. So the Java Runtime SDK is aimed at the desktop platforms, and we're all about writing JavaFX applications. Now, it's a fairly familiar architecture in that you need a Java runtime environment on your machine, and your application will run in that. But as Rex has suggested, we're not writing pure Java applications here because they're actually built upon the runtime core architecture. So we have binaries that are included in the SDK that are compiled for the different platforms that we include it on. So just to talk about that in a little bit more detail, the typical development and deployment workflow that you would go through is you would choose your IDE of choice. There are many of them. IntelliJ, Eclipse, and NetBeans are very commonly used. And you'll write yourself and hopefully test an application that you'll compile up into a jar file. And then that jar file can be deployed into your platform of choice. So that can be Windows, Linux, or Mac. And that runs inside the Java runtime environment you've got installed on the deployment machine. Now, as I keep saying, not pure Java applications. They are written in the runtime core libraries need to be included, which are in C++. And this, of course, means that we have consistent functionality and behavior across all of the platforms. So if I have a red dot on my application on the Windows machine here, that'll look exactly the same as the red dot that Morten will be displaying on his machine. So to make it work on Windows, I need to include the DLL files from the SDK. Linux, it'll be SO, and Mac, it'll be dilib. Actually, if I make a deployment that includes all three of those, I can have a structure that will work on any of the desktop platforms that I run it on. So this is what cross-platform is all about. So to demonstrate that, I'm going to move over to IntelliJ now, just to show you a little bit of code. Actually, no, I'm doing this in the wrong order. Okay, got it all mixed up. So considerations for writing cross-platform applications for Java. So I would say generally it does just work. JavaFX, which is the user interface platform that we're working with, is consistent in behavior across all of the platforms. There are small styling differences in the windowing when you run your application on your chosen platform. So an example here is you can see on my Windows application, screenshot I've got here, the close buttons are on the right-hand side. But if you run this inside a Mac environment, exactly the same application will be styled so that it looks like it's running on a Mac. So it's styled for the platform that actually works in. Major pitfalls that people find are generally when they're working with file systems. So if you were to write yourself an application on your Windows machine, and inside that application you wanted to gain access to a file which has got C:\/ and a path to some geodatabase data you want to work with, you shouldn't be surprised that if you try to run that in your Linux or your macOS environment, that won't work because the file structure is going to be very different. Possible ways around that are to refer to these files from relative locations from the runnable jar file that you're working with. So you'll use a sort of a / reference inside your application to pick it up from that relative location. The other thing you should note is that Windows generally uses backslashes, but other operating systems use /. But if you stick to the /, they work on Windows too. If you can't work with relative path locations, then environment variables might be a way for you to go, because these are consistently supported across all of the platforms, so that you could use those as a reference to the files that you're working with. So now going to Eclipse in the right place. Inside an application I've got here, this is an app which I'm actually making use of a local map package to display some data on the screen. So I'm picking that up from the relative path location /samples mobile map package, and then I've got some data for the Isle of Wight. So if we go and take a look at this, so I've compiled this application up as a runnable jar file. I've got my samples data here, which contains the mobile map package. If I just drill down to there. And the reason when this application works, the reason it works on my Windows machine is in my JNILibs directory. You can see I've got the DLL files. That means this will work in the Windows environment. So if I just go and double tap on my runnable jar file, you can see I've got an application that works on Windows. Now, I just need to do a bit of a swap here so we can go over to my Mac. So knock your coffee over. And we'll go to the Mac. Okay, so on my Mac, I have exactly the same file structure. I've literally copied the deployment from my Windows machine onto my Mac, and you can see here that I've got the runnable jar file. And the reason this works in the macOS operating system is you can see I've included the dilib files. So these are the libraries for the C++ core that are compiled up inside the SDK to make it work in this environment. So if I just go into my command line, I'll try and run this application. So I'm just doing a java -jar here. I've got exactly the same application, picking up from the relative location, and you can see that the data is styled in exactly the same way. The map looks as it did on my Windows environment, and it would be exactly the same if it was working in a Qt or a .NET application. The only difference is the application is styled very differently for the platform that I'm running it on. So let's just go back to my Windows machine and just summarize with some slides where I'm just going to talk a little bit about the advantages and the disadvantages of using Java for writing cross-platform applications. So the advantages are that the IDE and the Java runtime environment is free. I caveat that slightly because there are some changes to the Oracle licensing that you should have a look at, but if you make use of an open JDK, for example, then that still stands. It is free. Obviously, there are deployment costs or potentially deployment costs if you're using runtime, but that's standard across all of the SDKs. Now, the deployments can be identical for all platforms. So a structure that I put together can be copied onto Windows, Linux, or Mac, and it will work on any of those platforms. So I don't have to do any specific compiling for any individual platforms. And as I've already mentioned, JavaFX automatically styles itself for the platform that you're running it on. The disadvantages are, well, I guess the biggest one is that if the Java runtime environment is not present on your machine, the app won't work. But there are solutions for that. So there are sort of enterprise deployments of Java just to make sure that your organization has got the Java runtime environment and the right version of it installed on all of the machines. But if you can't guarantee that it's going to be there, there are self-contained packaging solutions where you can include the JRE in the application structure that you're providing to your users. So it'll be guaranteed to work, but obviously it'll make your deployment a little bit bigger. I guess the other thing is that we don't support development for mobile platforms. Now, technically that's possible, and that's an extension we could make to the product, but we haven't chosen to do that. We do have two other offerings from my colleagues, Morten and Lucas, who can do that. So this is just mainly for desktop deployment work. So with that, I'll hand back to Rex.
Great, thanks, Mark. Looks like we're going to hand this back over to Lucas for a little Qt QML magic. Great rundown. I think threw a little gauntlet or two down there on the cross-platform run everywhere thing. So it's good to see. We'll see what Lucas comes up with here. And you're up. Good to go.
All right. So I'm going to talk about Qt. And we'll go over what Qt is, what platforms you can target, how you can get it set up, which languages you can use, because there's actually two different APIs you can program against. Then we'll look at what your apps will actually look like, because there's some different styling and UI options. And finally, the pros and cons. So what is Qt? Qt's a cross-platform framework. It's written in C++ on the back end, and their mantra is code less, create more, deploy everywhere. The idea is that you write your application once and can deploy it to any device without having to make any code changes. They're complete cross-platform software framework. They use, again, C++ on the back end, which means it can be compiled pretty much anywhere. They provide a lot of ready-made UI elements and also other tooling as well, so that you can work with an abstracted API and write your code against that instead of having to write platform-specific code. It's actually used by many developers, over 1 million worldwide. It's very common in the embedded world. Embedded Linux is really huge for Qt. And it's also backed by an open source community. So this project is managed by the Qt company, but it's an open source product. So you can actually download the source and compile it for any platform that you want or make source code changes. So I mentioned this a few times. Qt itself can run nearly anywhere, but we, as Esri, we have to decide what we're going to support because, frankly, more platforms means more testing, which means more resources. So we have to pick and choose what we're going to support. And in this case, we support Windows 32 and 64-bit, Linux 64-bit. We've got actually a brand new beta out. It was on the plenary on Tuesday for ARM64 embedded Linux. So if you're interested in that, you can go to the early adopter site and get access to that right now. We also support Mac, Android, ARM v7, ARM v8, and x86, and then iOS, both devices and simulators. So how does this work? I mentioned this earlier, but you're coding against an abstraction API. So your app is sitting at the top, and you're using Qt's GUI and libraries, and they're abstracted API, and then that's where Qt does all the magic underneath. You can see there's a lot of boxes. It's calling into the different languages, using the different native platforms and the underlying compilers. And this is really one of the big differences from what Mark was talking about. We're actually having to compile it for each of these different platforms and create deployable packages for each of these platforms. It doesn't just run on the different platforms. So the setup admittedly takes a little bit of time because of the fact that you need to have the compilers for all these different systems. So first thing you'll need to do is set up Qt. You can do that by going to qt.io and create an account. Like I said, there is an open source option, so you can decide if you want to use enterprise or open source. You then install the different kits you want. So kits are how Qt refers to essentially the compiler and debugger and all the different tools for each of the different platforms. After that, you would set up the Runtime SDK for Qt. You also need to get the compiler for each of the platforms you want to target. So for Mac and iOS, it'd be Xcode. For Windows, you get the Visual C++ compiler and the debugging tools. And Linux, you'll need the GCC compiler. And for Android, you'll need the Android NDK and SDK. So as you can see, there's quite a lot of things you need just to get set up. Once you get set up, it's pretty straightforward because you're writing your application once and just building it for the different platforms. But it does take some time to get set up. And the IDE that we recommend is Qt Creator. It ships with the Qt framework, but there are Visual Studio hooks if you want to build with the Visual Studio IDE instead. Okay, as far as programming languages, we have two different APIs that we offer. Both use the same runtime core, which again is C++. So we get the same performance, we get the same end user experience, and we get the same features as well. So it's really up to you on what you want to pick. We've first got C++. This is a modern C++ API. It's based off C++ 11, so you get all of the new cool features. It's very fast. We chose to use it for our DSA open source app that you've seen in the plenary and maybe in the showcase. So it's very powerful. And we also have our QML API, and QML is what App Studio builds with, and Survey123 is built with App Studio. So they utilize QML. It's very easy to learn. It's a declarative language that describes what the UI looks like, but then you can write imperative JavaScript code. Here's some QML code. You can see it's very readable. It kind of mimics JSON or CSS. Here we have some declarative UI elements. So you can see we're not really controlling the flow. We're just describing, here's a button displayed in the top left. Here's what the text is. But then on clicked, we can run some imperative JavaScript code. So in this case, I'm creating a new point, and then I'm setting the viewpoint on the map view. One big feature of QML is something called dynamic property binding. So here I'm binding a property to an expression in this case. So once that expression evaluates as true, then the button will be enabled. But it's very nice to handle state because you don't have to control it in flow. You just say whenever this happens, and the notification works for you behind the scenes. And you can see the ArcGIS runtime code here. It looks exactly the same as the rest of the out-of-the-box QML code. We've made it feel exactly like all the other QML APIs, so it's quite simple to use. So what will your apps look like? If you're targeting C++, you have two different UI framework options. The first is the Qt widgets. There's a few different styles. We've got the Windows style, the Mac style, and what we call the Fusion style. These are only supported on desktops. They've been around since the beginning of Qt. Qt widgets have. And so we still have many users using widgets if they're only targeting desktop because it's quite rich in functionality. But a lot of the newer users are choosing to use what is called Qt Quick. Qt Quick is essentially QML. There's many different styles you can choose from, and it's much more friendly for mobile and touch screen devices. So you can choose between the default style, the material style, which uses Google's guidelines, the universal style, which uses Microsoft's guidelines, and the Fusion style, which is more of a desktop-oriented look and feel, and the Imagine style, which is based on image assets. So the important thing here to note is your app will literally look like this on every platform. It's not going to have the native iOS or the native Android button or combo box. It will look just like this. So you have some options between different styling, but you're not going to get the built-in support for the underlying native control. Okay, so a few demos here. This is Qt Creator. I've created an application that has a map view and a map. And I thought this was kind of an interesting example. Phones have an ambient light sensor so that it knows if it's basically in a dark or light room, it can change the brightness of the screen for you automatically. So in this case, I'm creating an ambient light sensor object, and then I'm connecting to the reading change signal. And when that reading changed, I switched between two different base maps. I have one that uses the dark gray and one that uses the light gray base map. So I want to show the dark gray when I'm in a dark environment so you get kind of a nicer user experience. So I can... Here you can see on the side we have our different kits. So desktop wouldn't really make sense. I don't believe my Mac has an ambient light sensor. Maybe it does. But you could deploy this to Android or iOS without any code changes. You just simply switch between the different platforms. So in this case, I'll just hit the Run button. I have two different devices. One's an emulator. I'm selecting my device. Got this handy screen mirroring application here. So what this is doing is it's building the application. You'll again note that I don't really know anything about the underlying Android ambient light sensor API. I don't really care. I just want to access it and know if it's dark or light. So it's compiling here and it's building the APK, and then it's going to use the ADB tools to copy that out to my device. Yep, I am not on the Wi-Fi here, of course. Sorry about this. All right, connected. So now it's on my device. I'll just launch it from here so I don't have to rebuild it again. Sensor demo. Okay, so it's light. So it's starting with the light gray. And then just to mimic a darker environment, I'm going to hold my hand over the sensor. And you can see it switching back and forth. So anyway, it shows hooking into the native sensors. I still have access to that, but I'm writing my application against this abstraction layer. And again, if you want to deploy to the different platforms, it's as simple as selecting the different kit here. So I could select iOS and deploy that out to my iOS device. So this is a pretty basic example, but I mentioned DSA. We also can build really nice looking applications that do a lot of different things. So this one's our open source app. We built it to target, there's two different targets really. There's a vehicle version, we call this DSA vehicle, and we have a handheld version that's made to run on a phone. So in this case, we actually have two different UI files that we load dynamically. In this case, it's loading the vehicle, and it's got sort of a touchscreen car interface, but we could also target handheld and then go out to the different iOS and Android devices. So I'll wrap up now. Pros and cons. Pros are that you write your code once. Same APIs and code. Runs on all the different platforms. It's a consistent style, look and feel. So this could be a con as well. It depends if you want your application to look the same like I mentioned, App Studio and Survey 123, that was a goal of theirs. They didn't want to have two different sets of documentation on how to use the app. They just wanted it to look the same. So it could be good, or maybe you need that native look and feel. You still get access to device sensors. There's an open source community, so they're very helpful on the forums and things like that. And there's two different options, QML or C++. If you're more of a web developer familiar with JavaScript, you can use QML. Or if you're more of a traditional C++ developer, you can use that as well. Cons are some of the more niche native APIs like AirPlay. If you want to do something like AirPlay or AirDrop on iOS, that's not exposed through Qt. It's not really a common concept, so you can hook into it if you want on your own. You'll have to write some Objective-C code and expose that and call that from C++ and kind of just bubble its way up. But out of the box, you don't get any of that stuff. So if that's important, you'll need to look for a different solution. Again, it won't match the look and feel of the native platform, but that can be a pro depending on how you look at it. The Qt framework can increase your app size. Because of that abstraction library, there's going to be an increase in size. And the setup can take some time. We talked about all the different dependencies you need to get installed initially. So that's all I've got. I'll hand it over to Rex and Morton.
Good stuff. Great. Thanks, Lucas. Great rundown on Qt. Supporting cross-platform. Throwing out a little shout out there to App Studio using Qt, Runtime SDK for Qt. I'm going to hand it off to Morton now. We'll finish up with a .NET and Xamarin discussion here.
Thanks, Rex. So yeah, I'm going to talk about the .NET side of things because .NET is just not just Windows anymore. So let me just really cover what it really is. Xamarin is a tooling that is mainly based on the Mono Runtime, which was this open source implementation of .NET. It basically reverse engineered the whole thing and started building it. This is before it was actually bought by Microsoft. But the cool thing is it actually compiles your .NET code into native Android and iOS apps. They're completely native apps in the end. And one of the things they do is they actually give you direct access to all the native APIs. So opposed to Qt that has like abstractions for everything, with Xamarin you instead write against the actual APIs. So in a way you can kind of say it's not really a cross-platform SDK. It's more you get to use C# against the SDK that's already on the device. But having said that, you also get all the standard .NET libraries as system I/O file APIs and streaming APIs and web APIs. Some of them under the covers might actually use the native APIs to do these operations, but you get all the standard .NET APIs that you generally use. But in addition to that, you get to call the built-in APIs, and they actually auto-generate these from whatever SDKs Android and iOS provide, and you would generally see when the new SDK comes out from the latest version of iOS, they will have the same day delivery of the SDK updated with all the new APIs available. So they're always right there as soon as it's available. It does mean that stuff that's not really part of the common .NET APIs, you'll have to code against specific APIs. So for instance, you were showing with the light sensors, you would actually write against the Android light sensor or the iOS light sensor. So that's some of the stuff that might not as easily be shareable, but of course you can abstract all that away. And luckily someone has already done that. One is called Xamarin Essentials that is actually run by Microsoft. And you can see there's a bunch of things they abstracted, like file system helpers, secure storage, barometer, location, all those things. Actually, they've written abstractions across all these, so you actually can just write the same code once. But you might get into sometimes you have to do something platform specific. In addition to that, if you want, you can actually share your UI because you use the native UIs, but they have a built-in abstraction on top of that as well. It's called Xamarin Forms. And it's very much like writing WPFF. It's SAML-based, so you can just write your markup in UI, and it under the covers will generate native UI. So if you use a XAML button, it'll actually use an iOS or Android native button under the covers, so it will look like the native UI. You do kind of get like a least common denominator of all those APIs, so it can be a little bit trickier with Xamarin Forms to really nail the native look and feel and tweak it the way you want it. But it's also very, very much more rapid because you really write the UI once and you can just reuse it everywhere. Oh, a little bit too far there. Whoa. What's happening? That's odd. So the Runtime SDK for .NET, we actually support multiple platforms. We obviously support Windows, so WPF and Windows Universal are some of the platforms we target. But we also support Android and iOS for this. And on top of that, we have Xamarin Forms, which builds on top of Windows Universal, Android, and iOS. And this that last year we added support for .NET Standard, and so most of our APIs are .NET Standard 2.0 compliant, so you can actually build a single library, a single DLL that can run on all these platforms. Just note that there are pieces of our API that is not part of the .NET Standard. Like, for instance, the native UIs will not be part of .NET Standard because they use APIs that are not within that range. But almost all of the APIs, like the map and the layers and symbology and geocoding and all those different tasks, they're all part of that. So that allows you to create business logic that you can just reuse on all these different platforms. And then, of course, we provide the Xamarin Forms piece. So a way to kind of show this that we have the different platforms, and they all run on different runtimes. So we have all the core C++, it's all the same stuff. But for WPF, we use the .NET Framework. We announced we're going to add support for .NET Core later this year, hopefully. UWP already runs on top of .NET Core, and of course, iOS and Android runs on top of the Mono runtime. And so all the stuff in the blue is really, to you, would look like shared code. And on top of that, we then add the little WPF, UWP, iOS, and Android specific stuff for like how to write into the map view and scene view. Those controls are native controls that are not really shareable. But most of this stuff, as you can kind of see on the side, is just all shareable code that it can reuse across all platforms. And to simplify UI, as I mentioned, we also have Xamarin Forms, so that actually sits on top of those three platforms and allows you to also share the UI for those three platforms as well. And that is also .NET Standard compliant. So to show that, I have a little demo here. And so I have an app here that we're actually kind of an overview. We both build a native app and a Xamarin Forms app for each platform. So what you see over here is I have a core API here. This is actually a .NET Standard library. It's a single assembly that we generate that has all my code for creating my view, downloading data from online to like provision my data, do geocoding and routing and a bunch of other helpful tasks that we implemented here. And so I take this library, just build it once, and then I reference it by the other projects. So you'll see the other project over here, for instance, I have Android. I have an activity, so those who do Android development, they will know what an activity is. And it's really just the same as an activity on Android, except I just use C#. In fact, I even have the AXML layout, which is just basically an XML markup for Android, sort of like a SAML for Android. And I even have a designer that can actually sit here and design. Similar in iOS, I have a storyboard. In UWP, I just have my UWP SAML. And so all this code actually runs the same way, but I have a UI adapted for each platform, written for each platform. But most of them business not even used. So for instance, here I have my UWP app. It's a little routing app we have a lot of office and I can never find the meeting rooms. So we figured it was kind of nice to have an app that you can actually search for how to get to various places. Go to the usability lab, for instance. And it calculates me 2 routes. In the rare event of it raining, it actually suggests you to go a different way so you don't get as wet. So it kind of optimizes your route based on inside versus outside. So it's all run like on Windows here, but all this logic is in the shared library. I have the same app as a native app running on my Android device here. So it's really the same thing. Can do a different. Oh, hold on. Sorry. Server room. Apparently we have a server room. I didn't even know that. M3NE. Oh, it is. I'm going to find Rex's office. I believe that is 45. Yeah. 04. Oh, 045. You're right. See? It's very confusing. So this is how to find Esri, Rex's office. Oh, Rex's office, yeah.
Uh-oh, secret's out.
Yeah, secret out. So yeah, of course, the shorter way is going through this open area, but if it's raining, you want to go the other way. Or if it's actually our problem is if it's 115 degrees outside, you want to go the other way. So there's just a little bit of outside here. And again, here's iOS, and this is the really cool part. It looks like I'm running iOS on Windows. I'm really having a Mac over here that I can put away as long as I want, because I don't really like Macs very much. So I just have it sitting here on the network, and I can remote over to it, run the simulator on this, and then remote that picture back here. And I can actually use touch on this thing, which a Mac developer cannot do because they do not have touch screens. But to actually sit with the simulator, where normally if you want to touch, you actually have to have a device to do it. It's super cool. In fact, I can go in here in my code. I've set a breakpoint when I calculate a route. So let's enter a new office. And boom, I can start here stepping through my code, running over on the Mac, but present it on here. So it makes it really easy to just sit on a single machine and do all this work. You can also, of course, develop on Android itself. You don't get the Windows support there, but you can do Android and iOS develop just on the Windows or the Mac device. But I think this is super cool that I can actually sit and debug this way. And most of this code is shared. As I mentioned, I also have a Xamarin Forms version over here. And so here I actually have another library. This is the shared view. And then you have what we call project heads. So there's 3, one for each. And really all these project heads do is they define like the app name and the store configurations, like what should the icon be and so on. But all the app is really doing, each of them is just like call the main app over in the shared project. So if I were to look at the start page in UWP, it basically just say, hey, launch that application, which is over here. So here's really just my SAML app, and I have most of the app is right in here, and I get all my binding and all that stuff I usually get from XAML, and that way this app will actually run on all these different platforms, and it looks almost identical. Let me just launch. I think I might already have this running. Maybe not. So I just want to show you side by side here. It's going to launch. It really doesn't look that different. One thing to note is in the native app, I use this thing called adapted UI. So when I make it wider, you see how the B route jumped out to the side. This is called adaptive UI. We don't currently have that in Xamarin Forms. I believe it's coming. So it doesn't do that over here because it's kind of a least common denominator, so that it just stretches like that. So that's where you get some of the extra benefits by doing native. You can use some of the functionality that those APIs have. It is possible to do some of these things, but it takes a little more work of kind of actually write your own abstraction around. It's called renderers. But it's a really neat way that you can do these things. And so this app will also run on all the other platforms and look much more the same, where I had tried to create slightly different UI fields on each platform for the native ones. So, what's good and bad about this? I'm going to be honest with this. Xamarin is actually free. It didn't used to be, but after Microsoft bought it, they said, we're just going to give it away for free. Just beware that you generally would use Visual Studio for this, and that is not free for commercial use, so of course you have to pay for your Visual Studio license. I think one of the real cool things, I can just sit in Visual Studio all day, where I'm personally feel really productive and just be on Windows and I just need a Mac somewhere, but to do iOS. But other than that, I can just sit and iterate on that same machine. And I think one of the real cool things is I always have access to everything that the platform provides. I can call straight into the Android JNA APIs if I wanted to, and so I actually quite often sit on the Apple and Android docs and read straight up what they can do and then call straight into them. So there's nothing that's really hidden there. So one of the other problems is, again, you don't get that 100% abstraction that Java and Qt might get. Like, you do write some platform specificness here and there. And one of the things is, there's a lot of stuff going on here. You have Visual Studio, and you have the Android SDKs, you have Xcode, you have remote debugging here, and sometimes all that stuff can get a little buggy. It has improved immensely over the past year. For instance, if you updated Visual Studio locally, then the tooling stopped working over there, and then you have to go on the Mac and figure out why. Oh, there's a new version. Make sure those are in sync. And actually, now it's like it'll detect that, hey, that's not in sync. Let me just remotely install that for you. So you just sit. The deployment just takes longer while it's saying I'm updating the tooling. So they helped a lot with that. If you don't have the right Android SDK version installed on your machine, it used to just fail the build, but now it actually will just start installing the SDK if it's missing. So they made a lot of stuff to just make that stuff easier, but there's still a lot of places where things can go wrong. And they're still working on improving that. And then, of course, if you want to do iOS, you need a second device to do that. You can't just be on Windows. So that's Personally, I'm not a Mac fan, so for me that's a con. So yeah, I think it's up to you.
All right, great. Thanks, Morton. Throwing a little shade on the Mac with that. Actually, one critical note here, I guess, is if you want your Mac to succeed, you need a banana actually on top of the Mac.
It's not an apple, it's a banana
so
now.
If your Xamarin builds on Mac are failing, make sure you got the banana in place, right? That's key. That's key feature. All right, great. So let's just take a brief look here. So we actually took a look at a couple of different cross-platform options with respect to runtime, Java, Qt, and .NET. So again, just to revisit a summary of how you choose a cross-platform SDK, take a look at, understand the expectations of your users, what do your users need, what are the platforms that they need to be able to target, take a look at your development capabilities and what you'd choose to be able to build on if you already have developer skill in some area, working with a managed API, such as one of the APIs that we support with Runtime. Take a look at that and utilize that. Otherwise, you might be looking at some additional training involved there too. A couple of questions really quick. We've given this session at a couple of developer summits now. Who's been to this session before? Okay, just a couple. Good. A lot of new folks. Anyone here using the Runtime SDK for Java? Okay, good stuff. That's a 0, I think. Is that what I see? Right. Okay. All right. Here we go. All right. We got the champion up here. Okay. Good stuff. Anyone thinking about Java after this? Maybe. Okay. Good stuff. I can feel the thoughts. I can feel the good thoughts. Runtime SDK for Qt. Anyone using it right now? We got a couple. Okay. Great. You guys are targeting multiple platforms, I suspect. Okay. Desktops and mobile. Desktop. Okay. Both desktop, mobile. Desktop and mobile. iOS. Okay, Qt for iOS. Okay, great. Anyone thinking Qt after this? Maybe, okay, we got some new recruits. Good stuff. Great. And then Runtime SDK for .NET. Anyone using it today? Uh-oh. Okay, it's a groundswell. Good stuff. Anyone thinking now about using Runtime SDK for .NET that hasn't already? Oh, okay, all right. So we've got a convert up here. Good stuff. It's a consolidation effort within the Runtime group. Nice. Right, exactly. Congratulations, join the team. It's good stuff, right? Okay, great. Thanks, guys. Good stuff. Now, I'm going to mention this other sessions. Now, granted, this is Thursday morning, and a number of these sessions have already happened, Tuesday and Wednesday, right? If you're looking at additional details on any of these SDKs, there are some building app sessions, whether it's Windows or Xamarin apps with .NET, or it's building apps with Java or Qt. These sessions were earlier this week, and they provide a more in-depth review of some of the capabilities of these Runtime SDKs. Granted, at the Developer Summit, all these sessions are available at no cost after the summit, right? So these will be published and available. The videos will be there that you'll be able to watch. So look out for this. Look out for these sessions in the future when these are published. A couple other things just to note here. Later today at 5:30 in Primrose B, there's a Runtime Road Ahead session where we'll talk a little bit about some of the capabilities that are rolling into Runtime if you're interested. Of course, as we're building in a common way and implementing a lot of this logic in a common core, that's going to be shared across all these platforms too. We'll be talking about some new technologies here that kind of further advance or enhance usability for some of these cross-platform Runtime SDKs that we talked about today. Of course, if you're looking for a context or a venue to ask anything you'd like, you might have been afraid to ask. Tomorrow morning at 10 a.m., we've got a very long title here, Everything You Wanted to Know About ArcGIS Runtime But Were Afraid to Ask. So we've got a GeoNet place for that right now. So if you want to get your questions in early, look for a tweet from myself, Morton, and a number of other folks on the Runtime team. I think you retweeted, actually. I believe so, hopefully. I think I saw that. There's a GeoNet place where you can get your questions in early. We're going to have a lot of the leads actually from the Runtime group there and available to get real-time answers, actually for a number of those questions. So feel free to come and attend that. That'd be great. We've got a opportunity for questions here because we've still got about 10 minutes. One thing I want to point to is there is actually a website here, and I'm going to bounce out of this site, this slide deck here really quick. If you go to the website, there is a Runtime SDKs landing page, and this is where all the Runtime SDKs are presented. At the middle of this section, there's a banner here that talks about choosing the right Esri API. This really talks about working with or looking at all the technologies that we provide as developer technologies, and really walks you through a discussion about some of the capabilities that are associated with both native and web solutions, choosing the SDK. So a lot of the things we talked about here, we've gotten a document that you can look at later after this session, if you'd like, and maybe read up on some of the capabilities and some of the benefits. There's actually a table here that talks about which platforms are targeted for which technologies that we have available. So this is something that's on our developer site now. Feel free to go out and take a look at it. It's a great place to go if you want to get maybe a little more in depth on some of the cross-platform technologies that we have available. So with that, I'm going to bounce back to our slide deck. And let's open it up for questions. Yes? Mm.
Curious if anyone's given any thought to doing something like a Python wrapper for the runtime, underlying runtime library to allow sort of scripting access to that.
We're entertaining ideas, actually. So ideas from the community, what's useful. There's a lot of different options out there, right, for building out native solutions or taking advantage of native technology. Obviously, we're looking for feedback. If there's a use or a need for that, it'd be good to kind of express some of the sort of the need that you guys have actually to be able to use that. So, yeah, so we do have, there's a technology called local server. Really think of it as like a mini ArcGIS server. I know you've worked with it before, Michael. And so with that, you basically have a mini version of ArcGIS server, ArcObjects, behind the scenes. With geoprocessing, you have the ability to take advantage of Python scripting through geoprocessing tools, and so that's available today. Granted, it's local server, it's ArcObjects, it only runs on Windows and Linux, and so it's only accessible in that context. And it is a mini server, so you're spinning up a service actually behind the scenes and working with it as such, but it is designed for local offline access, basically. Yeah.
I can add, if anybody isn't aware, there is a Qt itself does have Python bindings, so if you see those online, we don't currently support them, so it's not going to work right now. If it's something people are interested in, then we'd like to talk to you about it, but it won't work right now.
Yeah, good question. Anything else? We had another question over here. Yep, go for it.
You know, you were talking about if we wanted to hook into like the AirDrop for iOS products, and we'd have to write our own Objective-C and all that sort of thing, which is awesome. What would be a best practice for doing that in such a way that I don't pollute, I don't want to use the word, to contaminate my code base so that it doesn't get in the way of like building for Windows desktop or something like that? Is it something like build time dependency where I just drop that out and it doesn't?
Yeah, so the question is about accessing AirDrop or some native API with Qt and what the best way to integrate that into your project would be. The best way to do it is to basically use an ifdef, so it won't be compiled unless it is that platform. So you write your Objective-C code to access it, then you write a C++ wrapper on top of that. You use that C++ inside of an ifdef in your project. And then if you wanted to expose it to QML, then you could also do that by adding some different macros and things like that. But we do that in some places in the code base, so we need to access some things like, I think we need to access file or available memory at a given time to make sure that we're not going over a certain threshold, so we have to call into the native API. So we just use ifdefs for that.
Good stuff. Yes, question?
Is there a list of native APIs that aren't accessible from the Qt?
Or is there a list of beta APIs?
I mean, you know, these
of APIs?
aren't available.
Oh, okay. Oh.
So is there a list of those?
APIs that are not available with Qt.
Right. Yeah. So are there a list of APIs that are not available in Qt? There's not one consolidated list. In general, most things that have a concept on multiple platforms are available. So if it's a thing like a camera, for example, you want to take a picture, that's something that most mobile devices have. That's something they do expose. So if it's a platform-specific thing, it almost for sure does not have an API exposed. One big thing that isn't exposed, that is a common theme, is push notifications. So that is not available in Qt. You could write your own if you want, but that's not available. There's not a consolidated list, though. That would be nice.
Good stuff. Yeah. Oh, sorry. Go for it.
Is there a watchOS or tvOS option?
So the question is if there's a watchOS or tvOS option. Currently, no. I believe that Qt can be compiled to run on tvOS. I've read blogs about it, but we've never tried targeting it.
Do you see a demand for that?
I was just curious.
Just curious? Okay. Okay, good stuff. Good to see. Yep, question over here.
Rex, you mentioned React Native, didn't you?
I did. React Native, yes.
Is there some way that as a React Native programmer I could wrap in?
You can. We do have. So, is there a way to take advantage of React Native and utilize runtime or native capabilities that are available in runtime? We do have a number of customers that have wrapped native or have wrapped our runtime SDK actually, or native SDKs like Android and iOS and React Native, and used it in that capacity. We don't explicitly support that. Technically, it's possible at this point. We are, of course, entertaining ideas on need in that area. It's something that we see more frequently in the last year. So there's been some challenges there, I think, with respect to, number one, supportability, because you do have to, because you're managing your own wrapper, you have to be able to update and maintain that in some capacity, right? So it's extra work there. Number two, we have seen some issues with performance, actually, or we've heard about issues with performance, as opposed to working with directly with the native SDKs themselves, native development environments. That, of course, is subjective, actually, at this point. So we have no plans to have a runtime SDK for React Native at this point, but technically you can build it, actually.
You don't have anybody in-house that's actually doing that?
We do not. We don't have anyone in-house that's doing that at this stage. Yep. Cool. We'd like to hear more about what your need happens to be there, too, if it's something that you guys are maybe either have built or are trying to build or would like to build in the future. Right?
In your blogs, there's just one person, and they did it like 3 years ago, and I was
Yep.
hoping
Yeah.
there was somebody more recent.
It was more prototypical to see that it was done, it was possible, actually, right? But that was actually with 10.2x, our older.
Or was it?
Yeah. So, but it was really kind of a proof of concept,
Right.
actually, at the time. I have to admit, we haven't really seen many requests for React Native until just in the last 6 months. Actually, we've seen it really picking up. Yeah. So it's good. Yeah, it's good. It's an interesting topic, interesting technology. We'll have to keep an eye on it, for sure. There's another question? Yeah. How did you run the iOS emulator on Windows?
Cheap viewers into my Mac.
Right. Well, technically I didn't. I ran it on the Mac. But Visual Studio has a tool for, it's sort of like a screen mirroring. You don't actually see it running on the Mac, but it's technically running on the Mac. You'll see it in the Process Explorer, but it remotes it over to your PC instead.
Okay. Okay.
Yeah, so it's just kind of neat tricks. You don't have to sit and switch machines all the time. You can just keep it run. You can make it run on the Mac too, and then if you want to have it as a separate monitor, that's up to you. But there's in the Visual Studio that you can choose whether you want it local or remote.
Yeah, because it's a pain, the cheap viewer thing.
Yeah.
Great. Yeah, one more question. Yep.
Yeah. So when you were trying to deploy all the code to any of the environments, whether it's like iOS or Mac or is there any necessary or mandatory thing needs to be done on all the different environments, like framework or SDK? Do we need to have pre-installed part on Apple or on mobile devices if we are using the .NET code which we have developed on?
So the question is, do we need to install something else on the devices?
Yeah.
No, everything is packaged up in the app. So the app has everything it needs, and it will also package up like the mono runtime and stuff like will go on the device inside the app. So it's completely self-contained.
So it's taken care of the inbuilt libraries which we are developing or basically using in .NET.
Yes, everything will be contained.
Great. Good stuff. Good question. Great. Thanks, guys. We'll wrap that up here. Feel free to go to our survey app or our app and fill out a survey on this session. Looking forward to your feedback. Again, thanks for attending and looking forward to talking to you guys further. Great. Thank you. Thanks.